All right, greetings, Saintsmen. We are on lesson 9.4, which is the tangent ratio. Uh, the tangent ratio is the first of our trigonometric ratios. This is where you guys are going to need a scientific or graphing calculator. You guys have had the opportunity to purchase these things. That needs to have the following buttons on it when you get it. You'll see that there are going to be a TAN button, a SIN button, and a COS button. Those are the three trigonometric functions that your calculator will be required to utilize for you to be able to do any and all of these problems as we go through this lesson and go through this chapter. TAN is what's short for tangent. Please don't just say tan. When we have sine, cosine, and tangent, these are three ratios which are remembered by the mnemonic SOHCAHTOA. SOHCAHTOA. We're going to discuss this more in class, and we're going to focus on TOA today. This is a mnemonic used by geometry teachers for decades and decades. It's useful. It's an easy way for you to remember. You can write this down on your next test as soon as you start so that you can remember. And what it's referring to is that it means that the tangent of a triangle. So I'm going to go ahead and draw a right triangle here. Do my little auto shapes. Okay, so here's my right triangle. That way it's a nice crisp clean triangle. So let's say we have triangle A, B, C. For us to find the tangent of A, it means we go from the angle A. It means that tangent is equal to opposite, that's what the O stands for in TOA, over the adjacent, the A in TOA. So what would that mean? In this case, the opposite from the angle, you guys would continue to hear me say that, from the angle is going to be BC. And the adjacent side, remember the neighboring side, like we discussed earlier in the course, would be AC. So that's the ratio. It'd be BC to AC, would be that degree measure. All right. Now, students then start to question, well, Mr. Granados, why wouldn't this be the adjacent side? Well, remember, always opposite C, we have to first identify what is going to be our hypotenuse. Then what we've been identifying is our long leg and our short leg, but I haven't been given any length in terms of my legs here. Instead, all I can do is deduce from this angle A. This would be my side that is opposite, which means this other side would have to be adjacent. Now, I think some of you guys are already looking forward to the SO and the CA, right? And you guys can just relate those to these two right here. And the O, of course, is going to continue to stand for opposite. The A will continue to stand for adjacent. And now you know what that H stands for, which is hypotenuse. So you guys could actually even go and do those problems from the get-go. So let's take a look at a couple of problems real quick. First one that we're going to do is we're going to find. I'm going to just kind of section this guy off right here. We're going to make another auto shape. We're going to section off, and I'm going to create another right triangle. Right? That is nice and perfect. And I'm going to call these J, K, and L. And I'm going to find the tangent of K and the tangent of J. Okay? Given the following. If I had 24, 32, and 40 as my side lengths. Now, are those a right triangle? Well, absolutely, right? Because if I were going to go and I were to divide these guys all by 8, it would give me a 3, 4, 5 right triangle. So these are Pythagorean triple. Okay? So these do work. Now, what that means is if I'm going to go tangent of K, okay? I'm going to go tangent of K from K. 40 is going to be irrelevant because that is my hypotenuse in this. So first, from K, I have my opposite, which is 30. And then from K, I have my adjacent, which is 24, which I can reduce both of those. Okay. 30, 32, not 30, goodness gracious, 32 over 24, which would give me divisible by 8, which is going to be 4 over 3. Next, I'm going to find my tangent of J. Okay. So from the angle J, my opposite, which is 24, my adjacent, which is 32, which would be 3 over 4. Now, I cannot take a tangent of L. In fact, if we try to do it on our calculator, we're going to have some difficulty. Let's go ahead and take a look at what that would be, right? If I were to go ahead and try to take a tangent, okay, it won't even let me do it because this L, the opposite is the hypotenuse. So this just does not make sense. Okay, oops, I'm starting to delete stuff. Delete my 0. In fact, from 90, if I were going to say what's the tangent of 90, my calculator won't even do it, right? Let's try it. Tangent, oops, let's clear that out. Tangent of 90, oops. Not how I enter it in this one is going to say 90, and I'm going to take the tangent then. And it's this invalid input. It won't even let me do it on the calculator, okay? So, and that's because it just doesn't even make sense as a problem, right? There is no opposite. It is the hypotenuse, right? There is no adjacent because I have two adjacents, so that doesn't make sense, okay? Next. Let's explore some special triangles and see what we get. Okay. Let's go ahead and auto shape here. I'm going to do one of these guys, which you guys are familiar with. Okay. And let's find the tangent of the specific angle. Okay. Watch this. So if I do this, it means that this side is x and this side is x because this is a 45-degree angle, meaning that this has to be a 45-degree angle, meaning that here, this hypotenuse has to be x rad 2. Okay? So if I were to take the tangent of 45, if you punch it into a calculator, it's going to give you 1, and here's why. From the angle, from 45, this is going to be equal to x, my opposite, over x, my adjacent, which is 1. Okay? And again, on the calculator, my outer shape on there. I take that tangent of 45. Some of your calculators will do it this way too, right? It gives me 1, right? Has to be 1, which makes sense. Now, watch what happens. Let's take another couple tangents here, right? Let's take a tangent for our other special right triangle. I'm doing my auto shapes here. So what if I did this? What if I had a 30-degree angle here, and this is a 30, 60, 90, okay? Let's find the tangent of 60. Well, now watch. The tangent is 60. From the angle 60, think about what I have here. This is the short leg, this is the long leg, and this is the hypotenuse, right? I've done this before. So, if my short leg is x, I know my long leg is 2x, 2x, and then my long leg is x rad 3, all right? So, the tangent from 60 is going to be my opposite, which is going to be x rad 3, over my adjacent, which is x, which these guys are going to factor out, which is going to leave me with the square root of 3, okay? Now, let's do a little extension here. Let's take a look on the calculator. If I took the square root, goodness, that's always frustrating. Clear. If I took the square root of 3, oh goodness, I always have to enter this backwards. Clear. 3 square root. It's 1.73, okay? You guys see this thing? 1.73. If I do the tangent, oops, of 60, so I do 60, and then I hit tangent, I should get 1.7, etc., right? And I do 1.73 again. They're equivalent. That's how it was figured out in the calculator what this guy is. So let's actually figure out, take a quick look at what the tangent of 30 would be real quick. This one's going to be a little bit more entertaining. It's a little spicier, okay? Because again, if we're going from the angle, right, from the angle 30, it's going to be equal to my opposite x over my adjacent x rad 3. If these factor out, this is going to be equal to 1 over rad 3, which I cannot leave like this, right? I cannot leave it with a radical in the denominator. So I multiply by the multiplicative identity, which is 1, right? This is equal to 1. So I haven't changed the effective value. 1 times rad 3 is rad 3. Rad 3 times rad 3 is just 3. And this is what my answer is. Okay, let me recircle this so I don't block out my radicand. So rad 3 over 3. So again, let's check it out in the calculator. Clear it. Let's take the tangent of 30. So we go 30 tangent. All right, 0.577. All right. Now, if I take the square root of 3 and then I divide by 3, it's going to be giving me 0.577. You guys see it? So it's the same exact value. Same exact thing. Okay, last one of these problems. And I'm going to show you guys what I'm going to need now for these problems, because I need 2 answers. You guys will have to provide me the exact answer, which is what I want, and an approximation. Okay, so my last example for today. Let's go take the counter off. Okay, I have 12. I have x. I have 25 degrees. All right. And we're going to solve for x. How do we do that? Well, remember, we always go from the angle. So from the angle 25, okay, from 25, the tangent of 25 is equal to the opposite 12 over the adjacent x. Now here's what you guys need to write down and remember for the rest of this. Tangent of 25 does not mean tangent times 25. You guys do this to me, and all of you, it's a big indictment of all Saintsmen. Students do this to me. Tan times 25, right? I hate that, especially when you just say tan times or tan 25. It's tangent of 25. Okay, it's a function in itself. It's this ratio of when you have the ratio of the sides of a triangle when the degree measure is this. Okay, so we have to solve for x. We have to get x by itself. So I'm going to multiply both sides by x. So now I have x times the tangent of 25, or just simply put, x tangent 25 is equal to, these guys factor out, 12. Now, this is just a number, okay? I can just punch in tangent of a number. We just did this, right, in the calculator. We just did tangent of, like, for example, 30, and then we took a tangent of it, and it's just a number. It's some decimal number, okay? But I can just carry this thing around algebraically speaking, and I can just say that I can divide both sides by whatever that decimal is going to be, and it's going to factor out, because it's just some decimal. It's just a number. It's like rad 3, right? Rad 3 is just a number. I can divide by rad 3. So why can't I divide by tangent 25? So it's 12 over the tangent of 25. This is my exact answer. Now, I'm going to punch this into a calculator, okay? This is going to be about equal to. So we actually have some frame of reference here. This is going to be about equal to 12 12, right? We're going to divide. It's going to be divided by the tangent of 25. So we say, or yeah, 25 tangent. And that's about 25.73. Okay. So when we do this, I'm going to give you guys some rounding advice. We are going to round sides to the nearest tenth. Okay. So instead of 29.73, we have 29.7. And round degrees, round angles, sorry, to the nearest degree. And we're going to approximate trig ratios to 4 decimal places. So this is what this means, okay? When you take the tangent of 25, the tangent of 25 is about equal to, okay, just as a standalone number, it's as an approximation about equal to this, 0.46630, 0.4663. Okay. And that's that. So there you go, gentlemen. I will see you guys in class. Good luck.